All right, welcome everybody. Thank you for being here. If I get a nice big round of applause for Nicolas Brousse.
Thank you for joining me this morning. I will talk this morning about the way we monitor our infrastructure at Tumogul. Our infrastructure is heavily cloud-based, so I think there is some interesting stuff going on. So I will quickly intro my company and explain what are some of our challenges, what is our environment, all the stack we are using, what is the cloud environment and how we use Amazon. I will talk about how we automate our monitoring and keep it efficient, and how we make efficient on-call rotation, because I think when you have like growing team, it's a real challenge. Just for the quick story, I joined Tumogul 4.5 years ago, and I still have my strong French accent. And we were something like 7 or 8 people. Now we are like 150 people, so you can imagine the growth and the challenge to scale the server, but also the work with the team. And I think both have their one challenge. Then I will talk how we make our monitoring efficient and what is next. So quickly, Tumogul got founded in 2006. It was formerly a video distribution and analytics platform. Now Tumogul is heavily focused on video marketing and advertisement. I will skip all the speech, but it's really what makes our business and all our nights sometimes difficult. So what are our challenges? Right now we monitor between 700 to 1,000 servers. Those servers are spread across 6 different locations for Amazon EC2 region, one hosted provider, Liquid Web, and some VPS on Linode. We have little monitoring resources. We have like 6 servers spread everywhere to monitor all that. We are collecting over 100,000 metrics. We monitor over 20,000 services with Nagios, and we do multiple billions of HTTP queries a day. So it's a lot of it. All those HTTP queries need to be responded in less than 100 milliseconds. For us, not responding in time to this traffic will mean like loss of business opportunity, but in some worst case, it also means like we could overspend. When someone buy a campaign and we have to deliver their ads, they pay for a specific budget, and we can't go over. And if we don't get the information fast enough, we may start to spend more than what is expected. And so it comes from our pocket. So it's really important for us to monitor heavily our infrastructure and know what's going on. So all those servers are not all the same. It's not all Apache servers. So we have like over 80 different server profiles. Our stack is mainly like Java with embedded Jetty, some Tomcat. We have some PHP frontend. We have some Ruby on Rails API. We use heavily Hadoop, HDFS, MapReduce, HBase, Hive. You can imagine all the big data that we have to deal with to do like user targeting and better and optimize all our advertisement. We use Couchbase, MySQL, and a bunch of other tools I didn't list there, but that's the bulk of it here. Our monitoring use Nagios. We use heavily NSCA. Passive monitoring for us has been a huge win to save like resources. We graph with Ganglia, and recently we added SFlow, and we use also Graphite. I will talk more about all that later. And we use Puppet as a configuration management tool. So if you don't know Amazon, so it's a cloud provider. It's the biggest one, I would say. We use it since probably 4 years now. and it has been our default cloud provider so far. Amazon has different data centers everywhere in the world. They have this terminology of region and availability zone. Region will be US East, US West, or Europe. And in each of those regions, you will have like different data centers which will be called like availability zone. So we use multiple availability zone, multiple region, and we try to improve our high availability this way to, if there is a power outage like they got on, in Ashburn, I think end of June, the whole data center wasn't available for a couple of hours because of a thunderstorm or something like that. Anyway, we need to be able to fail over on different availability zones to be able to switch to different regions if we need to. So we are working heavily on this kind of features. So we use Amazon EC2, SDB, SQS, EMR, R3, a lot of other things. We don't use ELB. ELB is a load balancing solution from Amazon. We can't use that for a simple reason, is that there is a really slow ramp up in Amazon ELB. And we do advertisement, we have a lot of traffic spike. We can go from like, on one load balancer from 200 requests per second to 2,000 requests per second. And when it's at the size of a cluster, it can mean a lot. And Amazon has a hard time to scale that. There is a solution where you can like pre-warn like your load balancing cluster and things like that. The other problem is that you don't have log. And we need to know what's going on. We need to know if like we have a wrong routing rule somewhere, if we have traffic not going to the wrong load balancer or the good pool of servers. So we like to know what's going on. We need logs. So it's why we end up using like round robin DNS and HA proxy cluster, which work quite well for us. It has its own limitation, and we are working on that. I will talk about it further at the end. We use heavily EC2 tags, and you have an example of what it can give us. All our tools, API, use all our tools use the Amazon EC2 API, and we heavily rely on all the tags we set. So when we start an instance, we'll set a tag for the host name, for the Nagios host, it should report the profile we use to start this instance. And we keep some of this information also in SDB, which is a simple database, I think, from Amazon, and allow us to keep tracking of some of this information and to restart easily, like servers, and get the same profile exactly as we wanted. So how do we monitor all those cluster and server? We have basically one Nagios instance for each availability zone we work. And I say one, but it can be 2 or 3, depending on the size of the server we have to monitor, and we want to, if we want to add more. We just have to change this EC2 tag and say like, oh, the Nagios host is this one, and it will just report to this other host. I'm talking about the host reporting to Nagios because we use heavily NSCA, so it's a lot of passive checks, and the host need to know where he should report. So we have this Nagios in each region, which kind of prevent us any like networking issues. Like if we had everything like on Linode, for example, we'll have a lot of false alerts, and this doesn't work for us. But what we do is that on Linode, we have a monitoring for each of those Nagios. So we get something separate to make sure that our Nagios on each availability zone are working correctly. And if they are not responding, if they are not like performing as they should, we get paged and we can like check our monitoring is okay. We also have Graphite installed on all those monitoring servers, as well as Ganglia. So Ganglia is it's a clustering solution for graphing and collecting metrics. It's integrated really well with Airflow. So we use that heavily. And we recently added Graphite more for monitoring. We used to have, I don't know if you are